Hi guys, today we're looking at quadratic patterns. Our learning intention for today is that by the end of this lesson you will be able to solve real-world problems involving quadratic graphs and patterns. Let's look at an example question. So we're told that the number of computers sold per day for a major retailer over a 5-day period is recorded below. So our time is day 1, day 2, day 3, 4 and 5. So this can be our n, the order of our pattern, and the numbers sold per day are 10, 16, 18, 16 and 10. So this is Tn. So this is the value on a certain order. We're asked to draw a graph to illustrate this information. We're told that the x-axis is our days and the y-axis is our number of computers. From the graph, what is the busiest day for selling computers? Verify that the pattern is quadratic and find a formula that describes the number of computers sold for any given day. So that's looking for Tn. That's your general equation to find the number of computers or the values sold on any value of n. Part D, the manager expects the sales of the computers to continue to follow the same pattern over the weekend. We have to use our graph to explain if they should consider opening the store on a Saturday. And then part E, check your answer to part D using the formula that you find in part C. Okay, so let's look at part A. Draw the graph to illustrate the information on this table. So drawing our graph here, we'll have time on the x-axis and the number of computers sold on the y-axis. So at a time of 1, the number of computers sold is 10. At a day of 2, the number sold is 16. On day 3, we have 18. On day 4, we have 16. And on day 5, we have 10. So joining these points together, we can see that we have a U-shaped graph, which means that we have a quadratic graph. So it looks like we're going to have a quadratic pattern here. Okay, so part B, from your graph, what is the busiest day for selling computers? So what's the busiest day for computer sales? Well, we can see that the most computers sold was 18. So this is the top of your graph. That's the maximum point of your graph. So when did this value occur? So we're just going to drop down from our maximum point and read at what day we have our maximum number of computer sales. So this is on day 3. So on day 3, on Wednesday, we have the maximum number of computer sales. Therefore, this is the busiest day. In part C, we're asked to verify that the pattern is quadratic and find a formula that describes the number of computers sold. So finding a formula, this is what we were doing yesterday. We want to find the general term of your quadratic sequence. Okay, so let's look at the first part. We want to verify that it's quadratic. So to verify that your pattern is quadratic, we need to show that we have a constant second difference. So find your second difference. So our values are 10, 16, 18, 16, and 10. We find our first difference as 6, 2, minus 2, and 6. And finding the difference between our first difference, finding our second difference, we get minus 4. The second difference is always minus 4. It's constant, so we know that our pattern is quadratic. Okay, part 2, we're asked to find your formula. So here we're looking for the general formula for a quadratic term. So we want the general formula for a quadratic term. So we'll want Tn is equal to an squared plus bn plus c. So our quadratic formula will look like this. We need to find the values of A, B, and C for the data we were given. Okay, step 1, we need to find A. The second difference is equal to 2A. So we must remember this, that the second difference is always equal to 2A. In our case, -4 is equal to 2A. And dividing both sides by 2, we get A is equal to -2. All right, so I find my value of A as -2. So far, our general term looks like this. -2 n squared plus bn plus c. Okay, so step 3, I need to find my values of b and c. So to do this, I have to set up a simultaneous equation. So we're going to use our general sequence of Tn is equal to -2n squared plus bn plus c, and substitute in a value that we have when n is equal to 1 to make our first simultaneous equation. So T1 is equal to 10. This means when n is 1, our sequence will equal 10. Substituting these values into our general formula gives us -2 times 1 squared plus b times 1 plus c equals 10. So when n is 1, our value is 10. Okay, given here. Okay, so substituting that into our general sequence, we get -2 times 1 squared plus b times 1 plus c equals 10. All right, let's group together our like terms and solve this out. -2 times 1 squared gives us -2, plus b times 1 gives us b, plus c is equal to 10. And then bringing our 2 to the other side of the equation leaves us with b plus c is equal to 12. Okay, so I have one equation with our two unknowns b and c. Remember, I'm trying to set up a simultaneous equation so I can solve for b and c. So I need to make another equation that has our unknowns b and c. To do this, we're going to take our second value and substitute it into our general quadratic equation. So we're going to substitute it into this again. So when n is equal to 2, Tn, the value is 16. Substituting this into our general sequence gives us -2 times 2 squared plus b times 2 plus c equals 16. Okay, and we're going to just expand and simplify. -2 times 2 squared gives us -8, plus b times 2 gives us 2b, plus c equals 16. And bringing our 8 to the other side of the equation gives us 2b plus c equals 24. So this is our second equation with our unknowns b and c. Remember, you're trying to find what is b and what is c, so you can make your general formula. So we now have to solve for b and c, and we will do this by solving these two equations, equation 1 and equation 2. We're going to solve them simultaneously. Okay, so we have B plus C equals 12 and 2B plus C equals 24. To solve for your simultaneous equations, you need to cancel out one of the letters. So in this case, I'm going to multiply my second equation by minus, which gives us minus 2B minus C minus 24. Okay, and solving for what we have left, we have minus 2B plus B gives us minus B. Our C's cancel, and 12 minus 24 gives us minus 12. Flipping our signs, we have B is equal to 12. Okay, so I have my value of B here. B will be 12. We now need to solve for C. So into our original equation, B plus C equals 12, we substitute in our value for B. So wherever I see B, I write 12. This gives me B plus C equals 12. And moving our numbers to one side of the equation and our letters to the other side gives us C is equal to 12 minus 12. So C will be equal to 12, and then moving our 12 to the other side, minus 12, which gives us a C value of 0. So C will be 0. And this gives us our general equation of Tn equals minus 2n squared plus 12n. So we can find the value of any term in our sequence by substituting in the term number to our equation. All right, so let's write this in terms of the days and the number of computers sold. So we use the letters that the question tells us. So S, the number of computers sold, is equal to minus 2 times D squared plus 12 times D, where S is your computers sold, and D is the number of days. Okay, let's look at part D. The manager expects the sales of computers to continue to follow the same pattern over the weekend. Use your graph to explain if she should consider opening the store on a Saturday. So if she considers opening the store on a Saturday, if we follow the same shape, so on a Saturday, following the same shape, we can see that we would have very few computers sold on the Saturday, and we would have even less if we went down to the 7th day to Sunday. So should she consider opening the store? No, she shouldn't open the store, as she would be selling very few computers on a Saturday if we followed the same pattern. Okay, and part E says check your answer to part D using the formula. So we have our formula. The number of computers sold equals minus 2 times D squared plus 12 times D. So we want to use this formula to see if what we said in part D is correct. So we're saying that we shouldn't open the store because we're selling very few computers. So let's just double check that. So when our day is equal to 6, so on the 6th day, that's your Saturday, let's see how many computers are sold. So I substitute in 6 for D in my equation. So my number of computers sold is equal to minus 2 times 6 squared plus 12 times 6. And putting this in our calculator gives us minus 72 plus 72. So the number of computers sold On day 6 is 0. So we have 0 computers sold. So we can verify that it is not worth our while opening the store on a Saturday.